participating in the Space Walk of Fame's Oral History Project, and if you could, for the camera, please state your name.
Yes, my name is Hap Headlough.
Mr. Headlough, could you, when we were talking, we had discussed how you became involved in the space program here in Florida. Could you just recount that for us? What brought you here, how you got here?
Sure. I was working for Honeywell Aerospace over in St. Petersburg, and I was checking out Gemini guidance and navigation systems, qual testing and calibration for delivery over here to the Cape to McDonnell Aircraft, who had the contract for Gemini. And in the process, they would send their engineers over to observe what we were doing, and I just made professional contacts. And next thing I know, I got an offer to come over here to the Cape and work, and that was the end of '63, early '64. I can't really recall. And so I came over. I was assigned to the guidance navigation group, and I started, my first vehicle was GT2. And I worked the Grissom John Young launch, and I worked for the, on the next 5 Geminis. And North American, which later turned into Rockwell International, North American Aviation made me an offer to be a flight controls engineer. One of the reasons being they had a much longer contract, and back in those days, if you worked on a 2-year contract, at the end of the contract, you were just laid off. You were just automatically out the door. Back then, people bought houses and they would put like $200 down because they didn't want to lose money they had in the house. So they just walk away from their house. And gee, I got carried away there.
Had gone to North American.
Yeah, as a flight controls engineer. Mm-hmm. And I worked at that for 2 years. And then I was asked to be a test conductor, which at that time we had just one vehicle in flow. While we had the one in flow, we spent some time going back and forth between here and California checking out the vehicle. But once it left California, then the other vehicle started to be manufactured, and it was going to come down here. And at one time they planned, and it occurred, we're going to have 3 vehicles in flow. We didn't have enough people to put 3 full operational teams together. So we would leapfrog. One day you'd work on that vehicle, and then if there was a test the next day, you'd go to the next vehicle. And they ended up having 3 different spacecraft lead men. So they started to hire, they even promoted and so forth. They would go into the ranks and they would get guys they needed to make some of these upper jobs. And so I got an offer to be the spacecraft test conductor. And that was in '67. And I went, I was a test conductor all the way through up to Spacelab. And after that, then I went to California to work on the shuttle and design integration. I don't...
Yeah, let me bring you back now to your time with McDonnell.
Mm-hmm.
Okay, you arrive with McDonnell, and McDonnell is moving from Mercury into Gemini.
Right.
Did you find that for McDonnell, were they, and they had already by this time realized that they weren't going to get the Apollo launch?
Yes, they knew at that time.
How was that for them? Did you get any people that had said something like they were disappointed or anything of that nature?
Well, McDonnell back then, they'd gone through Mercury. They had experienced personnel, and McDonnell Aircraft had a reputation of never laying people off. Most of the people that worked here at the Cape had come from St. Louis. And so they fully expected that when that contract was over, that they were going to end up going back to St. Louis. So, no, they didn't have, it was never discussed. It was never discussed. McDonnell Aircraft here was a very small company. And old man Mac used to come in the blockhouse at particular times, you know, and it's kind of unheard of that the company, the man that they named the company after, you know, comes in, pats you on the back, and asks you how things are going and all that. So it was kind of intimate. McDonnell felt they had a family. They didn't know they had problems. A lot of the employees were not happy because the wages were very low, very, very low. They were the only deal in town. That was the problem. And here at the Cape at that time, we got swamp pay, it was called. Got an extra $100 a month because we were working out in the middle of nowhere. And back then, this place was nowhere. Guys were even deducting their mileage to and from work because they were traveling excessive distances. I guess the IRS later on put the clamps on that, but this place was just remote. McDonnell Aircraft was the only one in town hiring people, and he paid cheap. Engineers were hired cheaply. So when the contract came along for Apollo, McDonnell started losing people because North American based their contract on a particular pay scale for engineers. North American was a California company, and California companies paid pretty well compared to, I would say, most of the United States. So there was competition. And at the time, I got the offer from North American. I had also interviewed IBM, and they made me an offer also. I turned in my notice. I decided to go with North American because I wanted to work in flight controls or guidance and navigation. I didn't want to be computer oriented, and that's what IBM was doing. And my boss, who was Bob Burton, hunting and fishing buddy, by the way, I turned my notice into him, and he come in one day and he said, let's take a walk. And we went out and got in a company car and we drove out to the pad. And we're just walking around the pad talking. And he said, why are you leaving? And I told him why I was leaving. I was unhappy with McDonnell, as were a lot of people. I won't go into any details about specifics, why people were unhappy, but they were unhappy. And I just told him, I'm just unhappy. I told him why. And he said, well, I'll tell you what, why don't we solve these things you're unhappy with? We'll give you some extra money. We'll allow you to do some of these extra things. And I said, no, Bob, I said, I've already committed to North American. I'm already looking forward to working on the Apollo, so I'm going to go. And he said, well, what would you do if I went to NASA and had them force North American to withdraw your offer? And I said, well, IBM made me an offer too. And I know you can't intimidate IBM. I'll just go with IBM. But that's how they were losing people. It wasn't long after that, I left, and it wasn't long after that where NASA did put a hiring freeze on North American in hiring local people, because McDonnell Aircraft had convinced NASA that they were jeopardizing the Gemini program by hiring all the experienced people away. So that freeze was on, it was on for quite a while. I don't think it was years, but it was on for quite a while.
While you were working on Gemini, could you compare the workload for you as to what you eventually did with Apollo?
No comparison. No comparison. Gemini is a very small vehicle. It did not have a lengthy test program for it. It was two-man. It was going mostly in Earth orbit. It was going to prove that we could mate with another vehicle, things like that. So it wasn't in flow as long as an Apollo. It wasn't as difficult as an Apollo. It didn't have anywhere near the sophistication. And there was a lot of hardwire in it, believe it or not. Between the blockhouse and the vehicle, we actually had cables that were plugging in. And later on, when you got to Apollo, we had a lot of electronics. We had a lot of pseudo-computer interfaces and things like that. So it was much, much, much easier. We had more subsystems and more complicated subsystems on the Apollo than we had on the Gemini. And you may come in to run a test, and the test might be maybe a 2-hour interface test. That same test, when you got over to Apollo, might have run for maybe 4 or 5 shifts. So the workload was considerably more in Apollo, considerably more.
Do you have any particular recollections from any problems that you experienced, or any major things that you had to overcome with Gemini?
Well, one of the big problems was that back then, excuse me, back then the astronauts were gods. And when you really didn't get to talk to astronauts offline. You had no rapport with them. And what they said went. An example, we were running what was called a wet mock sim launch, and that's where they bring up all the ships at sea. They bring up all of the tracking stations. They bring in the whole test team. They go through exactly what they would go through on launch day. And they seal the blockhouse door, and you're in there. That's it. Nobody leaves. I was in guidance navigation. I also had a program, I had to manually do it, but a program that made the vehicle simulate that it was flying. And so we would go through the crew ingress just like we did on launch day. You'd run your pre-flight checks just like you would on launch day. And then we would go through T0, and I'd start my program, and it would put out signals that would torque the guidance navigation system and make the vehicle look like it was flying. During the pre-launch checks, we had an attitude ball in the vehicle, and of course the crew uses that like they do an attitude ball in an airplane to keep themselves in an orientation that they want to be in, and also look at horizons and things like that. And I put in a program to torque the ball to a couple different positions, and they're supposed to read what the ball says. And that way we know the ball is responding to the inputs we're going to give it later. And Grissom gave me the wrong answer on my first one, so I went to my second one. He gave me the wrong answer to that. So I went back to the first one, asked him to reread it, and he did, and he still gave me a wrong answer. And so I went to the second one again, and instead of asking for it in degrees, I asked him to count the hash marks to where the attitude was lined up. And he says, "God damn it, I've given you the answer. That's going to stay the answer, and that's all there is to it. Now let's get on with this test." Well, after the test was over with, and we went through the wet mock sim launch, and I'd already been in the blockhouse for about 8 or 9 hours, I had 8 hours of troubleshooting that I had to do to find out what was wrong with the attitude ball. So I spent my 8 hours of troubleshooting, and I ran that attitude ball through every test known to man except going and pulling it out of the vehicle. There was nothing wrong with the attitude ball. And I wrote on my I think they called it IDR back then, interim discrepancy report. We called them IPRs later on, interim problem reports. I wrote on there that it was pilot error. Well, I would have thought that I had just looked God in the eye and told him that he was blasphemous. I got called in the office and I was told I will never, ever, ever again say that an astronaut is wrong, and that I'm to change my conclusion on that piece of paper. And I said, change it to what? There's nothing wrong with it. And they said, you figured out, change it. And I said, I will not change it. And I didn't. I gave them the paper back and told them what they could do to it. I assumed somebody later on changed the paper. But that was a very, very big problem, because we did not have anywhere near as good a rapport with them as we did the Apollo. The Apollo was really good because they sent guys up to support us on a regular basis. So we got to know the astronauts real well. Shuttle, on the first part of that, we got to know the astronauts, but then later on it was back to the way it was on Gemini, where we never saw the guys hardly at all. They all came out of Houston, and they'd fly in that day, run the test, and they're gone. So that was probably one of the biggest problems, just for Gemini.
Any particular problems, silly things that occurred, like somebody did something just exceedingly stupid?
Well, gee, I'm sure we all did something like that. No, I really can't think of. Gee, you should have warned me about that one. I could have done some thinking.
That's okay. If you think
No, I can't, because everything was kind of short and sweet on Gemini. You would come in, you'd run a 2-hour test, and then you'd leave the blockhouse. You didn't spend that much time in the blockhouse to have any strange incidents pop up. And very seldom did you get a room full of people in the blockhouse. You would probably have a couple, 3 people doing a test and things like that, where on later programs you get a whole room full of people, all of them in there banging away on computers or headsets at the same time. And there were more opportunities for follow-ups. But no, Gemini was mostly short and sweet, professional.
Good relationship between McDonnell and NASA?
Boy, that was probably one of the biggest changes that we've seen in this program. I mean, in the space program. The number of NASA people that were here were minimal. Very, very, very few NASA people. And they didn't spend a whole lot of time with us. They just stayed kind of a little bit in the background and watched us, occasionally asking questions, occasionally asking us to do extra things like that. They weren't mainstream. And we were told that their job was to manage. It was to sit there and see that we did what we said we were going to do, and that we did it right. And if we did, there was not too much interface with the NASA people. Just as an example, we came off of one of the tests, and we have to run write post-test reports, which we would be in work. And one of the NASA people brought in to my supervisor a list of about 30 questions that after a test was over, what we had to do is strip our recorders out, and we'd go and we'd look at all our recorders. And we would look at every fraction of every second to see if we saw any blips, or what we did see was exactly what we intended to happen. And NASA would do the same thing. They would take these same recorder strips, and they would look at it. And unfortunately, back then, they weren't as well trained as our engineers were, because our engineers helped design it, helped build it, and help test it. And NASA didn't have that many people, so they didn't get as involved as we did. And they come up with these 30 questions. And they took it to my supervisor. He took it into the manager, and the manager walked down to the office to the manager of the NASA and said, my people have got better things to do than to train your people. You can answer these questions for yourself. And he walked out. And that was the last time that we were ever asked to do that by NASA. When we got to Apollo, I'm going to guess NASA must have increased by 300% the number of people that they hired. It didn't help us in the beginning because a lot of them they hired were new, and they got more involved with us too. We ended up training them as much as anything. The old NASA guys were fine. We got along with them good. But NASA was almost non-existent in Gemini, almost. And I'm told in Mercury that they had about the same crew, although they hired a few more of NASA people. They were even less visible. When we got to Apollo, you could just see leaps and bounds of NASA people. They just kept getting bigger and bigger and bigger, and a humongous bureaucracy out there, just humongous.
Before we move into Apollo, I have one more question for you in relation to Gemini. And, the GT-2, the capsule, was reused by the Air Force for a test for their mole. The
mole, the one that was canceled, yeah.
Did you have anything to do with that?
I did not work on mole at all, no. The mole program was going to be, I think, at Vandenberg. And Vandenberg was not on our menu back then. Although it was funny, in shuttle I ended up in Vandenberg, so.
Okay, I just wanted to.
Yeah, that was going to be a military Air Force type program, and it got canceled before any of us had an opportunity to do anything.
Now, when you joined North American, what was the first things that you started to work on?
Well, they had a lot of schematics of the vehicle. And I was guidance navigation, which is platform work on Gemini. I was going to be flight controls, which is hard mount type guidance system on Apollo. And so I had to learn my system. And I spent quite a bit of time just reviewing schematics, just figuring out how is this thing supposed to work. And also at that time we were trying to put together GSE down here to support ground support equipment to support some of the tests that we were going to run. They were building the vehicle in California, in Downey. They hadn't put power on it yet, the first power. So we had, I'm going to guess a few months. I don't know the exact time, but just to prepare here for what we thought we were going to be faced with when the vehicle came in. And then when they had enough of the vehicle put together in California, we would go out there on trips for, I guess the longest I ever spent out there was 3 weeks. But you'd come back here and you would bring back the experience you'd had out there and start writing some test documents here. And then it'd come time for another test in your subsystem out there, and you'd pack up and go out there and work for a week or 2 weeks or what have you. And we just back and forth until the vehicle came down.
What were your initial impressions of this Block 1 module?
Well, I was kind of overwhelmed because, like I said, it was leaps and bounds over the Gemini, leaps and bounds. And you ended up with a lot more interfaces. You ended up interfacing with a lot more subsystems. Not only was the system, the flight control system I worked on, much more complex than what Gemini guidance system was, but the number of subsystems on board was even greater. And so it was a big learning experience.
And could you describe your average work days, the durations of them?
Well, at first, when it was first brought in, they do a lot of mechanical things to it. And so they had it over in, I think, the parachute building or something like that to do some things. And we didn't, I'm a Sparky, I'm not a mechanical, so we didn't have much to to do with that, but we were still preparing our tests, writing our test documents, things like that. And once they brought the vehicle over, they put it in the O&C building high bay, and we started our initial tests there. The whole flow was we would be in the high bay, and then we would go to the VAB and stack it, and we would run interface tests with the whole stack. And then when we were done there, then we would take it on a crawler out to the pad, and then we'd run interface test in the pad, and then run subsystem test, and then run integrated test, and then we'd be ready for launch.
And you had mentioned that you were present in the blockhouse control room.
Yeah, Apollo used the LCC, Launch Control Center.
Mm-hmm.
That was for the booster people. And all the wheels got to sit out there too on launch day. The control room, which was in the O&C building, that's where all of the people associated with the spacecraft, non-booster, with the spacecraft were located. People didn't even know we were there. Walter Cronkite came out and did some questions and things like that. And what do you do in here? And we said, well, we're the spacecraft people. You know, the manned vehicle, all the testing, we're the ones that interface with that. Well, what's out there at the LCC? And we had to tell them that was for the booster, that was for launch. We said, those guys don't even, we used to kid them, they didn't even have headlights on their cars because booster people only worked in the daytime and they had an automatic program check their booster out. We worked around the clock out of the control room, so.
And what, with the 204 incident,
Mm-hmm.
when did you first realize that there was a problem?
Well, I got in just before shift change. Generally, you arrive about 30 minutes, 45 minutes before shift change, and go in and chat with the guy you're going to relief, and he gives you all the whys and wherefores and things like that. And I got in there just as it was occurring, and nobody knew anything. All we knew was that there was a problem at the pad. They cut off the OIS system. We had no communication. I mean, they deliberately cut it off. It wasn't that the fire contributed to cutting it off. They cut it off. They cut off the telephones. We were going to call home and say, check the television and tell us if something's happened. They cut the phones off. They brought in guards and they put them on the door, and none of us were allowed to leave. And we sat there for the next few hours, not knowing exactly what had happened. And then early in the morning they told us, you can leave. We still don't know what happened. I didn't know until I got home. So, and it was that way for everybody except the guys at the pad. Gunther Wendt, our pad leader, and his crew, you know, they were right on the spot when it happened. But I mean, the communication from this place went zero. They wouldn't allow anybody to talk to anybody about anything.
And for North American, I mean, what did this do to morale?
Disaster. This is a bad time.
And when was that? If we could talk a little bit maybe about that period as we're readying for Apollo 7. Was there a lot of changes within North American between 204 and Apollo 7?
You're talking the first vehicle after the fire?
Yes, the first one launch.
Lord, were there changes. Yeah, we had changes in everything. Everything. The changes were good. We didn't know it at the time. One of the changes was they brought in T.J. O'Malley, which is, he's a real hard case. And we thought that we knew it all. We thought we knew the ways to do things. And he looked around, and he didn't like the discipline he saw. He thought we were laxed, we were sloppy, we were lacking professionalism, and boy, he came down on us. And he came down, I'm talking big time. We had engineers going around trying to get a union up. That's how bad it was. If you screwed up, all of a sudden the guy would disappear. He wouldn't come in the control room anymore. I don't want that man in the control room anymore. And he'd sit in the office and do things. He would pull people, he would sit in the control room and watch us as we were going through tests. And if a guy didn't look good, he'd pick up the phone and he'd call his supervisor and say, get another man up here. And they changed the guy right on station. We lived in fear. He terrorized us. He absolutely terrorized us. And shaped us up. Big change. Big change in the fire. Yeah. We had the big change in the shuttle after it went. Unfortunately, in the shuttle, they overreacted and they decided, well, we know what the problem is and we're going to fix that problem, but what the hell, let's fix everything else even if it's not broken. And so we changed everything. And we didn't have to. We had stuff that worked fine, but we changed it. With Apollo, we were still so new that we weren't really changing old things that much. It's just we had changed things that we've been doing it this way. But he was right. We were not professional. And we were too forgiving for our mistakes. And he really, truly shaped people up. If you made a mistake, an example, the RCS people running a test, and they got bladders in the tanks, and that's where the propellants go. And they were running a test, and they weren't using live propellants, they'd use inert gases. And they took some extra cycles on the tanks, and they blew a bladder, and he was going to hang people. The RCS people were verboten in the control room. He kicked them all out of the control room. It was raise time. He canceled all their raises. Their supervisor went down there. He didn't have his raise canceled. He went down there and complained that he wanted his raise canceled too because he was responsible as much as some of the guys sitting in the office that weren't even running the test that got killed over the affair. That's how old Melly was. He would open the door, take his shotgun, boom, kill everybody in the office, slam the door, and walk off. And we soon learned that he would not tolerate errors. And everybody got better. Yeah.
Your work days, you had indicated earlier that you had just incredible work days where it might be 18, 20 hours, you might not even get home.
When the first Apollo came in, the Apollo had an SPS engine on it, a service propulsion system engine, and it was a little extra booster in space. It was what was going to be fired to head to the moon. And we were going to run a firing here of that. And so they took the SPS engine, they took it out to pad 16. And had to run all kinds of tests on that. And we were still developing our test plans. And we worked hard at that. We made up operational charts every day. There was a scheduling meeting. We made operational charts. We made what's called a bar chart and how things are supposed to flow. And we would make errors ourselves in what we thought the order was going to be. Then we would have a system that maybe had a problem, and so we'd have to sit there and wait while they troubleshot because we couldn't power up because maybe the power people had a problem and they couldn't supply power to everybody. They wanted to do their troubleshooting. And so all of the good plans of man just kind of went awry, and you had instantaneous scheduling of operations. Oh, you're done troubleshooting? George, and pick up the phone and say, get me whatever subsystem they wanted. Come out here and start running a test. And you'd be sitting in the office waiting for the call. And you might have been sitting there for 10 or 12 hours. You'd get up, drive out to the pad and go in and start running your test. Being in flight controls, I was going to monitor the attitudes of the SPS engine as it fired and the vibrations with accelerometers. And a NASA guy that I worked with on Gemini, John Stilley, we wanted to, they didn't have a recorder for us, and we wanted our own recorder so we could record all these parameters. And so we found an old Gemini biomed recorder over in the O&C building, and we had it moved out there and taken down to the transfer room, which was right below where the big engine sits. And we rigged it up so that we could get the parameters off of our engine and put into there. And then we took a hard wire, and I tell you, this was in the early days of Apollo. We took a hard wire and along with a power wire, and we led it up through the, I don't know, a couple hundred feet from where the engine was going to fire to the blockhouse. And we strung that wire up there, and then we took it in the blockhouse, and we put a little switch, almost like a light switch on the end of it. And I asked, we weren't going to be there for the firing, and I asked the test conductor, just before T0, would you please throw that switch on for us? And he said, sure, I'll be glad to do that. And it was totally outside of test. There were no test plans. It was just John and I wanting some information. And you could get away with that back in those days, and today they wouldn't allow this. And so we had this thing all rigged up. And when it came time to run our subsystem test, we'd already been sitting around there for a day, day and a half. And I'm talking the whole day, day and a half. I'm not talking 8 hours. I'm talking 24 to 30, already been sitting. And then Dan Jensen, who was the manager of this firing operation, said, okay, Hap, start running your test. Well, by the time I was done, I had been there 3 days. And I'm not the only one. One of the guys went in the nurse's quarters and found a cot. He slept down there. The rest of us slept, we put desks together and slept on top of the desk. We'd pile up a couple of test documents and lay down our head and go to sleep. And then get up and have coffee or go to the cafeteria at the Pan Am cafeteria and waiting for our turn for a test. So you could work, if you had a 2-hour test and it started when it was supposed to, and you finished it when you were supposed to, you were done. But if you were a guy down the line, you waited until it was your turn, and nobody went nowhere. We stayed there. So that's the way it was, and that was the forerunner of how Apollo was going to be. That was the easy part. The SPS firing was the easy part. And it turned out they had a sophisticated FM and digital FM, I don't think they had digital, FM monitoring system all set up to record all the parameters on the SPS engine when it fired. And they brought in these experts from JSC, and they were going to take these tapes. It was all on big reels and everything. They were going to take these tapes back to JSC and run this big study program on how well that SPS engine was going to do. I came in just after the firing. I went home to get some sleep while these guys prepped for the firing. And I came in just after the firing. And John was waiting for him, and he said, man, I can't wait to get out on the pad and get our data and see how we did. We went out there, and our strip charts were missing. So I went back up to the blockhouse, and I talked to the test guy. I said, did you throw that switch when I told you? He said, yeah, we threw the switch. I said, well, what the hell happened to our data? He said, well, at ignition, the FM system crapped out. I guess there was such a blast that it blew the FM system out. And so you guys were the only ones that had any data, so the JSC people went down there and stole your charts, and they're on their way back to Houston. So John and I never did get to see how well we did. But they took this megabuck FM system, and it crapped out, and John and I had this 2-bit biomed recorder that was patched together with wires, and we soldered and clipped and everything else to make it work. And that was the data they used for the firing. So.
You had mentioned that when you were out at the pad, or I shouldn't say out at the pad, when you were working, there was a lot of tempers would flare, and pencils would hit.
Yeah.
But that after, as we moved into launch parties, all that was forgotten.
I don't ever recall, as many times as I've seen some fierce battles going on, I don't ever recall anybody ever having obvious hard feelings over it. I'm not sure, but it took a heck of a man not to lose his temper. A heck of a man. We had some very, very nasty incidents. Some of the techs at the pad have even got into fistfights. Not very often, but it did happen. Walt Skinner was an SPS engineer, and he was running a test, and we had a NASA QE. His name was Don Whiting. There's two of them, a father and a son. This was old man Whiting, and he was the biggest pain in the butt put on this earth. Everything had to be just exactly perfect as he saw it. And not everything is written, things are written to a certain level, and a certain level requires a certain education to understand what was written. And he was at a disadvantage, as were most of the quality people, a disadvantage. They did not know the intricacies of, say, the subsystem. And so you had to go on a lot of faith of the engineer when he said, well, that's supposed to happen. Old man Whiting, he didn't go on a lot of faiths. And Walt Skinner said some things to him on the net that I guess it melted the wires, because the next day they couldn't make up their mind, O'Malley couldn't, whether I'm going to fire Walt Skinner or he's just going to apologize. So they decided he'd go ahead and have Walt apologize. And so that's the kind of stuff that went on. Bob Becker, his nickname was Cottonmouth, because he was so vicious while he was a quality control too. They really got on you. They really, truly got on you. Engineers had fights with each other, verbal, confrontations. One day after a 10 or 12 hour session, one of the ECS engineers who had a slight glitch with his subsystem was going to have to troubleshoot it after the test was over. And the test was over. It was close to shift change. He said, I'm going down to the office and give a tie-in to my relief. He's probably here and he'll come up and troubleshoot. And the test conductor, who turned out eventually to be a vice president of the company, told him, sit down there and start troubleshooting. And he said, I'm not going to troubleshoot. He said, sit down and troubleshoot. And he told him to go to hell, and the guy started to walk out. And he says, you hit that door, and he says, your ass will be fired tomorrow. And so the engineer turned around and walked back, and he said, well, I'm staying here, but I'm not doing anything. And he waited until his relief came up. I mean, people were tolerant. People were tolerant, but they did yell at each other. A lot of egos. Most engineers, when they've been around a while, think they know everything. And some of us think we do even after we stop being engineers. But that was the nature of the beast. That's why it was successful out there. Those kind of people.
And you had indicated also that when you were in between vehicles, things were a little less tense?
Launch day, majority of the time, we did have some night launches, but during the day launches, if, say, one got off at 10 o'clock, I think most of us were probably drunk by 12 or 1 o'clock. There was a launch party always. And for the next 3 days, it would be, the launch party, and then the next day you wouldn't even come in. You just stay home. And then your wife would find out why she appreciated you working long hours, because there you'd be home. And then you'd go into work the next day, and you'd go out to lunch, and you never came back from lunch for the next 3 days, and you would be drunk again. For the next 2 or 3 days, that would be the routine. And then you start going in the office and just kind of resting up and cleaning up paper. We always had paper left over, you might need a signature here or what have you. Clean the paper up and prep for the next vehicle. Yeah.
And does it take a toll on your domestic life?
Oh, yeah. As I had told you before, I'm sure if you'll check, you'll find during that period of time that the divorce rate here was about twice what the national average was. And I'm not saying it wasn't called for, because You know, your wife doesn't see you for about 3.5 months, which is the flow of a vehicle. And then for the 2 or 3 weeks that you're going to be off until the next vehicle picks up, you're drunk for at least a third of it. It's going to be difficult. The domestic life was not good at all. I think most families really didn't have much of a father around during that period of time. It was tough. Yeah, awfully tough.
You had we have about 5 more minutes to go. I just wanted to discuss a little bit about the change in work ethics between the Apollo years and as we move into shuttle.
Well, with shuttle with Apollo, as O'Malley used to like to say, whatever it takes. That was the name of the game. If it takes you'll be out here for the next week working until you drop over, whatever it takes. Shuttle, well, when Apollo ended, we lost the test team. We lost absolutely fantastic, tremendous test team. The worst thing the government ever did was to lay off that test team. They laid off most of them. We went from probably 200 or 300 engineers in our group on Apollo down to, I think we had 10 here during the difference between the last Apollo and the first shuttle. They lost all those engineers. Good people, good test team. They kept a core of us. Some of them they kept here, others we went to California and started prepping the shuttle to bring it down. So we didn't have the full test team. We didn't have the full support of the test team that we'd had at the end of Apollo for the front end of the shuttle. And we had to train people. And some of the people turned out pretty good. But as the shuttle picked up, they had to hire more and more people. And Rockwell had the contract for the first 3 years of the shuttle. And we had an awful lot of new people. And we trained them. And then the contract was given to Lockheed. And Lockheed brought in all of their management. And their management did not measure up, with all due respect, did not measure up to the standards of our management. But there they were. Example, one of the comments made was, well, after all, the shuttle is just another airplane. And I think people will decide today the shuttle is not another airplane, especially after the sucker blew up. But that was the attitude with the Lockheed crew. And then a lot of new people came in, and we old-timers were, first off, overwhelmed by the number of new people we had, and secondly, we were told by quite a few people, I don't care how you did it on Apollo. This is how we're going to do it. And the hardest thing we had was trying to explain to them that we weren't the smartest bear in the woods because we were on Apollo. We were smarter than them because we had made every mistake there was marching our way toward the right way to do it. And that they were not depending on our experience of mistakes to do it this way. They wanted to make those same mistakes for themselves. And that's exactly what they did. But how they defended themselves was, well, you made the mistakes because you didn't do it right. We're going to do this thing right. And we would tell them, here's what's going to happen when you do that. And a month later, that's exactly what would happen. So we had that problem, and it's because we got overwhelmed and we had a new management. And it's difficult for to tell a manager that, no, you're doing it wrong, or tell a director you're doing it wrong, and have him accept it. Now, the director I ended up with, really a good man. And he took me over to give a briefing to all the other directors. I was working still in the test conductor office to give a briefing to them. And when I did, we came back and we're driving back. He said, "What did you think of those, all the directors, you know," because I was there for their meeting too. And I said, "Well, they acted like a bunch of people that really didn't know what was going on." And he says, "That's exactly right." A year later, he left. He said, "I can't put up with any more of this." This is a Lockheed director, and he was a director across the way on the Cape side. So he went back to the Cape side. He couldn't stand it around here, and he was an old-time Lockheed guy. So the 10 years with Lockheed on the shuttle were not very happy, and it was not very efficient, and it was not well run. And the people were not as dedicated, not anywhere near. And, you know, it was good in a way. I'm sure that they didn't destroy as many families as destroyed during our day, but whatever it takes.
Tell you what I'd like to do. We are pretty much out on here.